Okay, time for Chapter 1, Section 7, Part B. Still talking about the distributive property. First of all, there's something called an imaginary one. In English class, if you have a declarative, an imperative sentence, that means you're giving a direction to somebody. You don't always use the word you. You could say like, go close the door. You didn't use the word you, but the person you're talking to knows that you're talking to them. That's called the imaginary you. Here in math, we have something called the imaginary one. For example, x is really the same thing as 1x. Negative y is really the same thing as negative 1y. If there's not a number in front of that variable, that means that you have one of them. Okay? The way that we can use this with distributive property, if we have negative and then the parentheses a plus 5, that is the same thing as if we have an imaginary 1. Okay? The imaginary 1 shows up right here, and then we can distribute. So we give the negative 1 to the a, and we give the negative 1 to the 5. We see that in the next line where it says distribute. And then you can simplify. Negative 1 times a is negative 1a. Negative 1 times 5 is negative 5, and you still have a plus sign in the middle. Remember from a couple of lessons ago that you're not allowed to have two signs right next to each other? Okay? So instead of the positive sign and the negative sign right next to each other, that's the same thing as just a negative sign. The imaginary 1 in front of the a is not necessary, so the 1 goes away, and you still have negative a. So the answer is negative a minus 5. Let's look at another one of those. Okay. First of all, there's an imaginary 1 in front. There's actually an imaginary 1 in front of that x also. We distribute the negative 1 to the negative 1x, the negative 1 to the 31, and we rewrite. There's that imaginary 1 there again. And then we multiply. Negative 1 times negative 1 gives me a positive 1x. Negative 1 times 31 gives me a negative 31, but I can't have a plus and a negative 31 right next to each other, so I just use minus, because a plus and a minus makes a minus. Another example. There's an imaginary 1 in front of that parentheses, and then we can distribute, give the negative 1 to the 4x, and the negative 1 to the 12. Simplify. Negative 1 times 4 is negative 4. Negative 1 times 12 is negative 12, but there's another negative sign in front of it, which makes it positive. Another use of the distributive property is to make mental math easier. Again, these mental math problems, you have to show your steps so I know that you're doing them correctly. An example of this, I use this all the time when I'm at the grocery store. Okay? Prices are strange. They're almost never whole numbers. Okay? If I was trying to buy 8 of something that costs $4.95, I can't do 8 times 4.95 in my head. But I can do 8 times 5, and 5 is pretty close to $4.95. And I can do 8 times 5 cents. Okay? So, here's an example that uses that idea. It costs $7.25 to ride the train, and I ride it 4 times. How much do you pay? Well, I can't do 4 times $7.25 in my head, but I can change $7.25 into something else. I'm going to change $7.25 into 7 plus 0.25. Then I can use the distributive property. I can give the 4 to the 7. I can give the 4 to the 0.25. And I can do that math in my head pretty easy. 4 times 7 is 28, and 4 times 0.25 is a quarter, and I know that if I have 4 quarters, that makes $1. So 28 plus 1 gives me an answer of $29. The key with these mental math problems is to write whatever you started with as 2 pieces inside parentheses. Okay? If I was going to look at the example I did before, I can rewrite 495. 495 is the same thing as $5 minus a nickel. And then I can distribute the 8. Right? The whole key is rewriting that piece so that there's 2 parts to it. Okay? New topic, a few new definitions. A term is a number, a variable, or the product of numbers and variables. And we'll do some examples here in a second. Terms are anything separated by plus signs or minus signs. A constant is a term that does not have a variable in it anywhere. A coefficient is a number that is being multiplied to a variable. And like terms have the exact same variable and the exact same exponent. Let's see what these things are talking about. For example, negative 8x squared plus 3xy minus 9x minus 3. Now, we talked about terms. Terms are pieces that are separated by plus or minus signs. So here's a plus sign in the middle. There's a minus sign in the middle. There's a minus sign in the middle. How many pieces do I have around that? Well, I've got the negative 8x squared piece. I've got the 3xy piece. I've got the 9x piece. And I've got the 3. So there are a total of 4 terms in this problem. Now, the sign always goes with the number that comes after it. Okay? Let me get rid of some of these marks here. So, the negative goes with the 3. This negative goes with the 9x. This plus goes with the 3xy. And this negative goes with the 8x squared. The sign always stays with the number that comes after it, never the thing that's before. So, those are terms. Let's look at constants. Let's see, constant is a term that doesn't have a variable in it. Are there any of those pieces that doesn't have a variable in it? Sure, this negative 3 doesn't have a variable with it, so the constant is negative 3, a number that doesn't have a variable with it. Let's look at coefficients. Coefficients, the number being multiplied to a variable. So, there's a variable, the x squared. The negative 8 is the coefficient, the number in front. X and y are variables. The 3 is in front, so the 3 is a coefficient. X is a variable, so the negative 9 is the coefficient. Okay? The coefficient is just the number part that comes in front of the variables. We talked about like terms. Like terms have the exact same variable and the exact same exponent. So if you look at what we started with, are there any pieces that have the exact same variable? Well, this has an x, this has an x, this has an x. But the variable might be the same, but the exponents aren't. This one is an x squared. This one is an x that has a y with it, and this is just a plain x. All 3 of those variable parts are different. None of them match exactly, so there's no like terms. Let's talk a little bit more about like terms. If you look at the following questions, are any of these like terms? AB and AB squared. Well, the variables are the same. They both have a's and b's, but the exponents aren't exactly the same. The second one has a b squared. The first one just has a b. 2xy squared and negative x squared y. So look at the variable parts. This one has a plain x and a y squared. This one has an x squared and a plain y. So the variables and exponents are the same, x's, y's, and squareds, but they don't match exactly. In this case, the 2 and the negative sign in front don't affect the problem at all. These are like terms. If I look at the variable parts, I've got a squared and a squared. They're exactly the same. The 3 and the 5 are not a part of the variable. Those are the coefficients. The variable parts match exactly. So that makes them like terms. If you do have like terms, you can combine them. You can put them together. So if I have 3a squared and 5a squared, I can put the 3 and the 5 together and get 8a squared. We'll talk later about why the a squared doesn't change. Okay? A few more examples of that before we're finished. An expression is not called simplified unless there's no like terms and no parentheses. That's the goal that you're trying to get to. Example, simplify 3y minus y. Now remember, for that second y there, there's really an understood 1 because there's no number in front of it. Now, these are like terms because the variable part of this one is y, the variable part of that one is y, so I can put these together. 3 minus 1 gives me 2y. Another example, simplify negative 7 mn to the fourth minus 5 mn to the fourth. They are like terms because the variable parts are exactly the same. So I can look at the numbers. Negative 7 minus 5. So I have 7 negatives and 5 more negatives, which gives me a total of 12 negatives. And the mn to the fourth comes along. So I change the subtraction to addition in the middle, and I use the opposite of the second number, combine like terms, and I get negative 12 mn to the fourth. Last example, 7y to the third z minus 6yz to the third plus y to the third z. Now, do I have pieces that have the exact same variable parts, the same variables with the same exponents? The like terms are right here. The piece in the middle has y, z, and 3, but it doesn't exactly match the other two. This last piece here really has an understood 1. So we put the understood 1 in there. And we can combine the terms that are alike. If we put the 7 together with the 1, 7 plus 1 gives me 8. So there's 8 of those, 8y to the third z, and the other piece just stays the same because I can't do anything with it. If it's not like terms, I can't put them together. Okay? Your practice problems for this section, or the rest of this section, part B, page 50, 33 to 63 odd.